Welcome my dear friends, my dear students. I hope you are all well. Previous day we learned about the in optics chapter we learn about refractive index and the ray passing about glass slab and the value of lateral shift. We established the theory. Today's topic is total internal reflection. And we do the theory, the application of total internal reflection and also the problems related to it. So, let us we start the topic. What is total internal reflection? If this is the interface between two medium, this is medium 1, this is medium 1 and this is medium 2. Suppose this medium is taken as water. This medium is taken as water with refractive index mu2 and this medium is taken as mu1 and it is taken as air and mu2 is greater than mu1. That is, this is the denser medium and this is rarer medium. Medium 2 is denser, medium 1 is rarer medium. Now, what can happens when a light passes from denser to what? Rarer medium. Suppose this is the source of light, and when light goes normally through the surface, it goes undeviated. That is, if this is the point we say A, this is C and D, the light goes A, C, D direction without any deviation. But when light is incident on another point, as it goes from denser to rarer, if this is normal, then the refracted rays bend away from the normal N1, N2. This is the value of angle of incidence I1 and this is the angle of refraction is taken as R1. If we increase the value of angle of incidence, then also the value of angle of refraction increases. So, if we increase the value of angle of incidence, that is from I1, if it is taken as I2, then also the angle of refraction is increases, that the ray bends more than the previous case. This is R2. Now, when the angle of incidence is certain angle for which the refracted ray goes along the surface, that is angle of refraction is 90 degree, is called critical angle. Critical angle is the value of angle of incidence of the denser medium when the angle of refraction is 90 degree, that is the refracted ray goes along the interface of two medium. So, what is the value of angle of incidence? Say the angle of incidence is IC. Suppose the angle of incidence is IC for which the refracted ray goes along the surface of the goes along the interface or the surface divided the two medium. So, the angle of refraction in this case is 90 degree. This is the normal at the interface of two media. So, when sin IC is the angle of incidence, angle of refraction is sin 90. This is equals to mu 2 1 as the ray goes from medium 2 to 1. So, we know that mu 2 1 refractive index of mu 2 1 equal to sin IC by sin 90 degree. Now, so what happens if we increase the further angle of incidence? What happens when we increase the further value of angle of incidence? Now, if we increase the value of angle of incidence, so say this is I theta is greater than the critical angle IC. If I theta is greater than the critical angle IC, then the angle of refraction could not be greater than 90 degree. The maximum value of angle of refraction is 90 degree. So the ray cannot goes to the another medium, it totally reflected back to the same medium with same angle of incidence. So in spite of refraction, a reflection occurs in which the total ray will come into the same medium. So, and this is also the case of reflection. So it is called total internal reflection. Why total? Because no other part of the incident ray goes or transmitted to the rarer medium. Internal, because the reflection occurs only in the medium 2. So it is the case of internal medium. And reflection, you also know that reflection takes place in only a homogeneous single medium. If the medium is heterogeneous, then reflection occurs. So in this case, I theta, that is the angle of incidence of denser medium, must be greater than the angle of critical or critical angle. This is known as total internal reflection. Now, what is the value of, what is the relation or between the refractive index, what is the relation between refractive index and critical angle? This is a very important relation for our to solve numericals. If the ray goes from medium 2 to 1, so we can write it mu 21 is equal to sine of IC by sine 90 degree. Mu 21 equal to sine of IC by sine 90 degree in case of when angle of incidence is equal to critical angle. Now 2 mu 1 equal to 1 mu 2. Now 2 mu 1 is equal to 1 by 1 mu 2. It can be proved from the principle of reversibility of light. 2 mu 1 is equal to reciprocal of 1 mu 2 is equal to sine IC by sine of 90. We know that sine of 90 is 1, so it is equal to sine IC. Now, if medium 2 has refractive index mu, that is if mu 2 equal to mu and medium 1 is AR, that is mu 1 equal to 1, as the refractive index of AR is 1, then we can write it as 1 mu 2 equal to 1 mu 2 is written as 1 mu 2, 1 by 1 mu 2, that is 1 by 1 mu 2 equal to sine of IC. So it is known as 1 mu 2 equal to mu 2 1 by mu 2 by mu 1. 1 mu 2 is equal to written as mu of 2 by mu of 1. This is a relation between absolute refractive index to relative refractive index. So 1 by 1 mu 2 equal to 1 by mu 2 by mu 1, or it is written as mu 1 by mu 2 equal to sine IC. Now we take mu 2 equal to mu and mu 1 equal to 1. So we can get mu1 equal to 1 and mu2 equal to mu, then sin IC, or mu equal to 1 by sin IC. That is, refractive index is equal to the reciprocal of the sine of the angle of incidence. Refractive index is the reciprocal of the equal to the reciprocal of the sine of the angle of incidence. Now we can do some application. So what can we get? Mu equal to 1 by sin IC. Now we can go with application of total internal reflection. The application of total internal reflection is first as written as sparkling of diamond. Diamond has very small angle of incidence. It is equal to 24.4 degree angle of incidence. That is IC equal to 24.4 degree for diamond. So when light enters into the diamond, the angle of incidence is large or greater than the critical angle. So it suffers repeated total internal reflection and gets collected inside it. But the emergent ray cannot goes out from any surface. Only certain surfaces it can goes out. So the diamond is sparkling. Diamond is seen as sparkling when we see from emergent faces. This is the case of total internal reflection. Next we see mirage in the desert, in our cold treated road. We can also, it is known to all that number 2 is mirage or mirage. When a tree, the ray from a tree is, this is an observer eye. If this is the earth surface, then in summertime the layer close to the earth surface becomes very hot and relative to the air in the upper surface. So this is treated as rarer medium and this is as denser medium. Now when light comes from this tree, it comes from denser to rarer medium. So in every case the refracted ray bends away from the normal. But at a stage when the angle of incidence I is greater than the critical angle IC, then the reverse phenomena will occur. So the ray traces the reverse path and goes bending upon upwards, it goes to the traveler's eye. But our eye cannot trace the bending path, it traces only the straight line path. So he can see an image of tree into this position, inverted image of can see the inverted image of tree, and as the refractive index of the air is changed due to temperature change, refractive index is dependent on temperature. Due to increase of temperature, refractive index decreases. So as the refractive index changes, so we can see that this is vibrating or shimmering, the shimmering of the tree. So this is a optical illusion, this is an illusion due to total internal reflection. It's an important application is total internal reflecting prism, total internal reflecting prism, in which an isosceles right angle prism is needed. So first case is inverted image, get inverted image by 90-degree deviation, 90-degree deviation. This is a total internal reflecting prism. If this is an object, so a ray is incident normally on the shorter face AB and it makes an incidence at the point P and suffers a deviation, 90-degree deviation. This angle is 45-degree angle of incidence and this is 45-degree. As we know that the critical angle for a glass prism is nearly equal to 42-degree. So as the angle of incidence here is greater than the critical angle, so the ray at point P, in spite of refraction, it totally internally reflected and emergence out from the ray, from the face BC without any deviation or normally. So in this case we can see the image by 90-degree deviation, in which case this is seen in periscope. In earlier days the warriors और राजा का जो सेनापति थी, योद्धा थे, वो ये पेरिस्कोप यूज़ करते थे. तो nowadays in playground when a barrier is in front of a some person, he can watch the entire game using this type of prism. This type of prism is a periscope. Another we get inverted image. We can get inverted image by 180-degree deviation. What is the picture? This is a picture of PQR is an isosceles right angle or total reflecting prism. This is the hypotenuse face, this is the perpendicular, this is the base. Now ray coming from an object AB first make normal incidence on the hypotenuse surface, then from this surface it can get totally internal reflecting, it can reflect it totally, and also it gets repeated reflection from this surface and finally emerge out from this. Another ray from B also comes, gets total internal reflected and gets out from this. So this is B dash and this is A dash. We can get, if this is, we can get the inverted image by, and the finally incident ray and the emergent ray has deviation 180-degree, becomes opposite direction. So the angle of deviation is 180-degree in this case. This type of prism is also greater. So this is the also the use of total internal reflection. sometimes there is no deviation and we can get the image, we can get also the image. If this is object AB, this is the PQR. So at first the ray from suppose deviation gets reflected away, and another ray from B AB, and this is also get inverted image, and as this ray is A, this is A dash B dash. Here the ray suffers no deviation, but the incident ray and parallel ray are incident ray and the emergence ray are parallel, but here the order is reversed. The ray coming from A goes at the bottom and the ray coming from B goes as the up of this ray. So the order of ray is reversed. Order is reversed. But there is no deviation occur. We get an inverted image. This type of prism is used in binoculars and also projection lantern. So this is also the use of total internal reflection. Now we take some problems on numericals. Suppose we can say that calculate the speed of light in a medium whose critical angle is 30 degree. Calculate the speed of light in a medium of refractive index or refractive index, whose calculate the speed of light in a medium whose critical angle is 30 degree. Calculate the speed of light in a medium whose critical angle is 30 degree. So how can we solve it? We know the refractive index mu equal to 1 by sin IC. So we put the value of IC here, 1 by sin 30. The value of sin 30 is half, so it becomes 2. Mu equal to 2. We can get mu equal to 2. Now we also know that mu equal to C by V equal to 1 by sin IC. Mu equal to C by V equal to 1 by sin IC. We can find out the value of V. So from here we can know that we can get V equal to C sin IC. The value of C is speed of light in vacuum, 3 into 10 to the power 8 into sin IC into sin 30 degree. That is, if we calculate the value, we can get 1.8 into 10 to the power 8 meter per second. This is the basic law to find out any type of numericals. This is 1.5. 1.5 into 10 to the power 8 meter per second. Next. this angle is 60 degree. This is a prism ABC. Now a ray is incident normally on this surface. Normally this surface. Now in question it is it has to find out that the ray of the emergence, the path of ray of emergence, and if there is any total internal reflection occur or not. The ray, a ray, suppose this name of ray is PQ, is incident normally on AB surface. So find out the path of the reflected ray. So we can write that for total internal reflection, IC, angle of I is greater than IC. So if we draw a normal on AC surface, the normal will go as this. So as this is 60 degree, the rays, as the ray incidence normally on this point, it goes undeviated along this point. So if this is 60, this normal, if we take, this is N1, N2 and BC are parallel. So if this is 60 degree, this is 60 degree also, and as this is normal ray, so this angle must be 90 degree. So if we take as R point, so for QDR 90, 60, 150, so this angle must be 30 degree. This angle must be 30 degree. Now angle of incidence I equal to 30 degree. But what is the value of IC? What is the value of IC? If this is glass prism, it is said that this is a glass prism. For glass, mu equal to 1.5. So sin IC equal to 1 by 1.5, 1 by mu. So IC equal to sin inverse 1 by 1.5. So it nearly equal to, if we get, it is nearly equal to, we get value of 41.8 degree. Nearly equal to 41.8 degree. So the value of IC here is greater than I, which is not the case of internal reflection. So no internal reflection will be seen, but the ray will suffer, but the ray will also suffer a refraction here, as it is go from, if this is air, as this go from denser to rarer, the refracted ray bent away from the normal. So the refracted rays go along RS direction. I hope you all understand this. In this way, we can do any numerical related to total internal reflection. Total internal reflection. If in a beaker, this is the normal. Now if a ray of light goes along this is IC, so the refracted rays goes along the interface of the medium. Now this value is, say that 30 semi, and the height of the liquid is 40 semi. Calculate the refractive index of the liquid. Calculate the refractive index of the liquid, and also the light, velocity of light in this liquid. Also the velocity of light in this medium. So if we name this as A, B, C, now this BC line and the surface and the edge of the beaker will parallel. So this angle and this angle must be alternate angle and equal. So if this is a perpendicular, this is a right angle triangle, so this is the perpendicular, this is hypotenuse and this is base. So we can get sine of IC is equal to sine of IC, we can get as perpendicular to hypotenuse, that is perpendicular to base, and sine of IC is 30 by AC. This is hypotenuse, this is perpendicular and this is base. So perpendicular upon hypotenuse is sine IC. Now what is the value of AC? AC equal to root under 30 square plus 40 square, that is 50 cm. So sine IC equal to 30 by 50, that is 3 by 5. Sine IC you get 3 by 5. Then we can easily calculate the refractive index 1 by sine of IC, that is 1 by 3 by 5, that is 5 by 3 is the refractive index of the liquid. So we can get value of mu L equal to 5 by 3. Now what is the value of velocity in that liquid? We can also know that mu equal to C by VL. Therefore VL equal to C by mu, that is 3 into 10 to the power 8 divided the value of mu 5 by 3. So 3 into 10 to the power 8 into 3 by 5. 3 into 10 to the power 8 into 3 by 5. So we can get the value is 1.8 into 10 to the power 8 meter second inverse or meter per second. I hope you will all understand this, and from this theory I certainly know that you do all type of numericals. If you faces any problem, please comment me in my box. Thank you.